Greetings. Today we will be talking about the Williams Olefins plant explosion and fire that took place in Geismar, Louisiana on June 13th of 2013. The Williams Olefins explosion in Geismar, Louisiana is one of the most widely studied chemical plant incidents in the United States due to its clearly identifiable failures in process safety management. This case provides an important real-world example of how overlooked hazards, inadequate procedures, and incomplete engineering controls can align to produce catastrophic results. The following slides will summarize what occurred, identify which OSHA PSM elements were involved, and outline the lessons learned for industry to prevent future tragedies. On June 13th of 2013, a reboiler in the Williams Olefins plant ruptured, causing a massive explosion and fire. 2 employees were killed and 167 workers were injured. The explosion occurred when heat was introduced into a reboiler that had been isolated from its pressure relief system. The rupture produced a boiling liquid expanding vapor explosion, a BLEVE, and the CSB identified major failures in process safety management systems. So, the explosion occurred during a non-routine operation in which operators attempted to restart a portion of the propylene fractionator system. The reboiler that ruptured, known as Reboiler B, had been out of service for years. During maintenance changes made in 2001, block valves were installed that allowed the reboiler to be fully isolated from the pressure relief system that protected it. Years later, this new configuration remained undocumented, unanalyzed, and unrecognized as a significant hazard. On the day of the incident, workers opened a valve to begin heating the reboiler. However, because it was isolated from its relief device, pressure inside the equipment rapidly increased. The vessel failed catastrophically, causing a BLEVE and releasing highly flammable hydrocarbons that ignited almost instantly. The force of the explosion killed 2 workers and injured 167 others, many of whom were contractors positioned near the blast site. The CSB determined that 3 PSM elements were directly implicated. Management of change, MOC, because of the 2001 installation of block valves were never analyzed for new hazards. Pre-startup safety review, a PSSR, because the system was restarted without formal verification of safety protections, and operating procedures, because no written procedure existed for the non-routine startup activities being performed. The CSB concluded that the incident resulted from systemic weaknesses in Williams' process safety culture, hazard analysis procedure, and management oversight. Of the 14 process safety management elements, the 3 most critically involved in the Williams explosion were management of change, MOCs, pre-startup safety reviews, PSSRs, and operating procedures. Each of these elements failed in ways that directly contributed to the reboiler being placed in a hazardous condition without proper safeguards, while other elements, such as mechanical integrity and process hazard analysis, were tangentially involved. CSB identified these 3 are the clear root causes. They represented systemic organizational weaknesses rather than isolated oversights. One of the major failures identified by the CSB was the company's improper handling of the system modifications made in 2001. During this earlier project, Williams installed a block valve arrangement that unknowingly allowed the standby reboiler to be isolated from the pressure relief system. Because this modification was not evaluated through a formal MOC process, its safety implications were never recognized. When critical equipment changes bypass the MOC process, the organization loses the opportunity to identify new hazards, update documentation, or revise operating procedures. In this case, a simple undocumented piping change effectively removed the reboiler's last line of defense. Another key PSM failure occurred when the system was restarted without a thorough pre-startup safety review. A proper PSSR should have confirmed that all equipment was properly protected, that isolation boundaries were verified, and that all relief devices were in place and functional. Instead, the plant resumed operations with the reboiler still isolated from the relief system. This oversight happened because safety information was outdated and operators had no documented procedure reminding them to verify relief protection. If the PSSR had been completed correctly, the lack of a relief valve would have been immediately detected, preventing the accident entirely. Lastly, the operating procedures at the Williams facility did not adequately cover non-routine operations such as startup, shutdown, or troubleshooting offline equipment. Without written guidance, operators relied heavily on past experience and verbal knowledge, which made important steps inconsistent and prone to error. The absence of clear procedures meant the team did not verify the reboiler's isolation status or pressure relief coverage prior to the heating the system. This allowed hot hydrocarbons to flow into a vessel that could not safely relieve pressure. In modern PSM programs, written procedures are essential for ensuring safe, repeatable, and predictable operations. So the lessons learned for the industry were the Williams explosion demonstrates that even minor design changes can dramatically increase process risk if not safely analyzed. Organizations must prioritize engineered controls such as relief valves and positive isolation over administrative controls or operator judgment. These safeguards remain effective even when the human attention shifts or documentation becomes outdated. Additionally, this case highlights the importance of robust PSSR processes and clearly written procedures for all non-routine activities. A strong safety culture ensures that workers feel responsible for questioning unclear conditions and verifying critical safeguards before beginning work. So, bulletize that, the small takeaways were small design changes can create major hazards if not reviewed. Engineered safeguards are more reliable than administrative controls. PSSR must be thorough and not treated as paperwork. Written procedures are essential for both routine and non-routine tasks, and strong process safety culture reduces catastrophic risk. Lastly, we have our references.